Hello my dear students. As in the last video, we have discussed about the factorization chapter of class 10 ICSE board. I will continue the same chapter with more numericals today. In last video, you can remember that I have discussed about the two corollary of remainder theorem. The first corollary was if a polynomial fx is divided by x plus alpha, then the remainder is equals to f minus alpha. And the second corollary was if a polynomial fx is divided by ax plus b, where a is not equals to 0, then the remainder will be f minus b by a. I hope you remember these two corollaries. Now, let's start with today's sum. The first sum is like this. What number should be added to 2x cube minus 3x square minus 8x so that the resulting polynomial leaves the remainder 10 when it is divided by 2x plus 1. That means this 2x cube minus 3x square minus 8x is a polynomial, right? And it is when divided leaves a remainder of 10, and it is divided by 2x plus 1. That means obviously this 2x plus 1 is one of the factor of this polynomial 2x cube minus 3x square minus 8x. Okay, so if I compare this root, that means 2x cube plus 1, that will be comparable with this corollary 2 where it is divided by ax plus 2, right? So I can write here like this: by corollary 2 to the remainder theorem, when fx is divided by 2x plus 1, so the remainder, in that case, what was that? F minus b by a. So here also it will be like f x means f minus half, because here b is 1 and a is 2, right? So the value will be like this. If I write this polynomial again, 2x square minus 2x cube minus 3x square minus 8x, I will put the value of x, that is minus half, in the place of this x. So minus half cube minus 3 half square minus 8 half. So it will be like minus 1 by 8, 3 into 1 by 4, and it will be minus 8 just. Okay, Now it will be, I will simplify it, minus 1 by 4 minus 3 by 4 and it will be plus 4. Now remember one thing that I have told, that what should be added. That means within this polynomial there is something which is added so that the remainder will be 10. Okay. Now let k is added with the polynomial. So I will put plus k like this, and it will be the remainder then the total value will be 10, which is given already. So I can write this equation like this: minus 1 by 4 minus 3 by 4 plus 4 plus k is equals to 10, right? If I make the LCM of it, it will be like this: 4 minus 1 minus 3, 16 plus k is equals to 10. So minus 4 plus 16 by 4 plus k is equals to 10. So it will be plus 12 plus by 4 plus k equals to 10. So it will be 3 plus k equals to 10. So k is equals to 7. So 7 is the number which is added to this polynomial 2x cube minus 3x square minus 8x, and it is when divided by 2x plus 1, it will leave a remainder 10. We will go to the next sum. The next sum is like this: the polynomials ax cube minus 7x square plus 7x minus 2 and x cube minus 2ax square plus 8x minus 8 when divided by x minus 2 leaves the same remainder, and we have to find the value of a. You can remember in last few sums we have discussed with a single polynomial, and when it is divided with a single root, it will leave some remainder. But here in this case, two polynomials are given, and when they are divided with the same polynomial, that is x minus 2, that gives a same remainder. Okay. So it is divided, both these two polynomials are divided by x minus 2. So you can remember that it will follow the corollary 1, right? So since we can write that since the polynomial fx is divided by x minus 2 and fx dashed is divided by x minus 2 leaves same remainder. Okay, and what is fx? Fx is ax cube minus 7x square plus 7x minus 2, and fx dashed is equals to x cube minus 2ax square plus 8x minus 8, and both are divided by x minus 2 and will leave the same remainder. So, by following corollary 1, I can write that f is equals to 2 because x minus 2 is given, right? And I will put the value of x in these two polynomials, right? So, as because these two polynomials will leave the same remainder, I can write that ax cube minus 7x square plus 7x minus 2 is equals to x cube minus 2x square plus 8x minus 8, but two polynomials leave the same remainder, so I will put the same value 2 in these two equations and the remainder will be same. So, here I will put a in the place of x, I will put 2 cube minus 7, 2 square plus 7 into 2 minus 2 is equals to 2 cube minus 2a 2 square plus 8 into 2 minus 8, right? So, it will be like this, 8a because 2 cube that is 8. Now, 7 into 4, 2 square that is 4, 7 into 8 that is 28 plus 14, 7 into 2 minus 2 is equals to 8 minus 2 square that is 4, 4 into 2 that is 8a plus 16 minus 8. If I just make these two variable parts in the left and all the constants in the right hand side, it will be like this, 8a plus 8a, 16 minus 8 plus 8 minus 28 plus 14 minus 2, or 16a is equals to 16 minus 28 plus 14 minus 2. So, 16a will be 32 and a will be 2. So, the polynomial ax cube minus 7x square plus 7x minus 2 and x cube minus 2ax square plus 8x minus 8 when divided by x minus 2 leave the same remainder. That's why these equations I have given equal signs and I have find out this value of a, that is equals to 2. Okay. The next problem is like this. If R1 and R2 are the remainders when the polynomials x cube plus 2x square minus ax minus 7 and x cube plus ax square minus 12x plus 6 are divided by x minus 1 and x plus 1 respectively, then find the value of a given that 2r1 plus r2 is equals to 2. Like the earlier sum, here also two polynomials are given. But in this particular case, the remainders are different and there is a relation between the remainders that 2r1 plus r2 is equals to 2. r1 is for the first polynomial remainder and r2 is the second remainder of the second polynomial. Okay, and look at this when it is divided by x minus 1 and x plus 1. So, in both these cases corollary 1 will be followed. Okay, if I take the polynomial, the remainder of the first equation is r1, then it will be like this. Let fx is equals to x cube plus 2x square minus 5ax and f x dashed is equals to x cube plus ax square minus 2x minus 12x plus 6, then R1 is remainder when fx is divided by x minus 1. So here f1 will be there. So I will put the value of x1 in the first polynomial. So what will be like this? R1 will be x cube plus 2x square minus 5ax minus 7. So I will put the value of 1 in this polynomial. So it will be 1 cube plus 2 1 square minus 5a into 1 minus 7, that is 1 plus 2 minus 5a minus 7, that is 3 minus 5a minus 7, that is equals to minus 5a minus 4, that is the remainder 1. Now what will be the remainder 2? In case of remainder 2, it will be fx dashed. In case of x dashed, I will put the value of 2. So then R2 is remainder when fx dashed is divided by x plus 2. So f is minus 2. Now R2 is equals to x cube plus ax square minus 12x plus 6. If I put the value of minus 2 in this polynomials, it will be minus 2 cube plus a minus 2 square minus 12 minus 2 plus 6. It will be minus 8 plus 4a plus 24 plus 6. So it will be like 4a plus 30 minus 8, that is 4a plus 22. Okay, now I got two remainders. First remainder is minus 5a minus 4 and the second remainder is 4a plus 22. And also in the question a condition is given where 2r1 plus r2 is equals to 2. So I will put the value of r1 and r2 in this condition. So I will put 2r1 plus r2 is equals to 2, or I can say 2r1 value is minus 5a minus 4 plus r2 is 4a plus 22, that is equals to 2. If I solve it, it will be minus 10a minus 8 plus 4a plus 22 is equals to 2. So after solving this, it will be like this: minus 10a minus 8 plus 4a plus 22, that is 2. So from here I can tell that minus 6a is equals to 2 minus 22 plus 8. So it will be minus 12, because 8 plus 10 is equals 8 plus 2 equals to 10. 10 minus 22, that is minus 12. So minus 6a is equals to minus 12, and from this I can get 12 by 6, that is 2. So a is the value. So hope my students you have understood these numericals. Like this numerical, today the remainder theorem is closed. Tomorrow in my next video I will discuss about the use of factor theorem in factorization. Till then, bye and good luck to all of you.